Alright, let's be real for a second. How many times have you been burned by a sensor that's just lying to you? 1 minute the readings look perfect, next minute they're jumping all over the place and threatening to send your whole process off a cliff. You swap the sensor, you check the controller, you double check the program, and somehow the problem's still there.
In this video, I'm going to show you the wiring and maintenance techniques pros actually use to eliminate unreliable sensor data for good. We'll cover how to wire temperature and pressure sensors the right way, the biggest wiring mistakes that cause bad readings, and a simple maintenance checklist that prevents most failures before they happen. Let's get into it.
Reliable sensor data is the foundation of everything. Industrial systems, HVAC, automation, you name it. If your system can't trust its temperature or pressure readings, it's flying blind. Bad data leads to bad product quality, unexpected shutdowns, and hours of troubleshooting you'll never get back. Here's the good news though. Most sensor problems aren't random.
They usually come down to a few common and completely avoidable mistakes in wiring and maintenance. Today, we're going to fix that.
Milliamp the plan. First, the fundamentals of bulletproof wiring. Then step-by-step wiring for temperature sensors. After that, pressure sensors and the 4 to 20 milliamp loop. And a simple pro-level maintenance checklist. And finally, fast troubleshooting for common sensor headaches. By the end of this video, you'll be wiring and maintaining sensors with total confidence. Before we strip a single wire, we need to talk about the real villain here. Electrical noise. In industrial environments, noise is everywhere. Motors, V's, contactor, high voltage cables. And that noise loves to jump on to low voltage sensor signals. That's how you end up with jumping readings, random spikes, and phantom alarms. These unstable readings can lead to false positives and wasted time. So, always use clean power and proper grounding to avoid these problems. So, good wiring isn't just about making a connection. It's about protecting your signal. For almost all analog sensors, you want a shielded twisted pair cable. The twists cancel noise, the shield blocks interference. Step 2. Ground the shield correctly. This is where people mess up. Golden rule, ground the shield at one end only, usually at the PLC or control panel. If you ground both ends, you create a ground loop which actually attracts noise instead of blocking it. One shield, one ground.
Loose terminals, bad crimps, corrosion, all of these introduce resistance and intermittent faults. Every connection should be clean, tight, and secure. After tightening, give the wire a gentle tug. If it moves, it's not done. Get these fundamentals right, and you eliminate a huge percentage of sensor problems before they ever start.
Part 2. Wiring temperature sensors. Let's talk temperature sensors. Most of the time, you'll run into
RTDs and thermocouples do the same job, but they work very differently, and the wiring rules are not interchangeable.
An RTD works by changing resistance with temperature. The challenge? The wires themselves also have resistance. That's why we have different wiring options. 2-wire RTDs are the simplest configuration. They are also the least accurate. This is because there is no compensation for wire resistance. Only use this for short runs where accuracy isn't critical. 3-wire RTD. They are the most common. Adds a third wire to compensate for lead resistance. Great balance of cost and accuracy. This is the industrial workhorse. 4-wire RTD, the most accurate. 2 wires for power, the sensor, and 2 wires to measure voltage directly across it. Completely eliminates lead resistance error. Best for labs, calibration, and critical process. Let's move to thermocouples. Thermocouples generate a tiny voltage based on temperature difference. There are 2 rules you absolutely cannot break. Using copper creates a new thermocouple function and ruins the reading. Rule number 2, watch polarity. Thermocouple color codes can be confusing. For example, IP, yellow is positive, red is negative. Yes, red is negative. Always check the manufacturer's chart before wiring.